What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
It is not so important whether this spike flew out directly from the wheel of the car ahead, or it was lost earlier and now. Your matelot just caught it with the tread, and the centrifugal force sent a piece of metal in flight towards you. The bottom line is one: the culprit cannot be found, and you will face expensive repairs. It turns out that from studs only harm, they also spoil the asphalt surface. But without studs in a number of situations cannot do without them. If with snow mush on the asphalt of our city's winter friction, tires cope quite confidently, then on clean ice and snow rolling studded rubber shows a confident advantage. But only the problem of keeping the studs themselves in the body of the tread does not go anywhere and requires constant attention. And not only because fallen out studs are a danger to other cars moving on the same road. Lost studs tire loses with them and traction properties, which in turn can lead to an emergency situation. Of course, for this you need to lose not one or two studs, but quite a lot. It is considered that a studded tire completely loses those advantages on ice and rolling, which give studs, with the loss of 70% of these steel claws, so to bring the tires to such a state is clearly not worth it. In addition, asymmetrical loss, for example, after braking in the skid on an unfortunate place, can lead to the appearance of imbalance, which will make you feel vibrations on the steering wheel and general discomfort. But to understand how this problem is solved today, it is worth remembering the history of the emergence and improvement of winter-studded tires. While there were relatively few cars and their speeds were low, snow chains were successfully used to move in the snow. They have not lost their relevance even now, and they are widely used in particularly extreme conditions. But chains and speed are incompatible things. And so in the 30s there was an idea to equip tires with spikes that can cut into the ice, thus radically improving traction. As a matter of fact, there was nothing fundamentally new in this idea. Winter horseshoes with spikes were quite commonplace by that time. As in many other cases, the new technology was first tested on racetracks. The first studded tires were made by drilling through holes in the tires and inserting bolts with a tapered head and a slot on the inside. From the outside the bead was tightened with a nut, so that the head was recessed into the rubber and did not threaten to burst the tube. The serviceability of such designs was very small, 200 or 300 kilometers they withstood, and it was quite enough for one winter race. After the end of World War II, the fleet of cars, their speed and the road network began to grow rapidly, including in countries where there is a real winter. This necessitated finding a solution that would radically improve tire traction in snow and ice, but would also have sufficient durability. And such a solution was found in the 50s of the last century. That's how the modern type of studs came into being. These spikes looked like an ordinary rivet, in the center of which there was a hard alloy insert. These studs were used on ordinary mass models of tires, but by 1969 it became clear that the combination of a steel stud and rubber quickly freezing in the cold is far from ideal in terms of functionality. It may seem that the spike itself is not that high-tech. It consists of only two parts, a body and a solid core. On one side there is a flange, a kind of cap, with which the stud is fixed in the rubber block of the tread, and on the other side there is a protruding part of the core. But, from an engineering point of view, the simpler a product or part is, the harder it is to improve it. So, the first spikes were made of steel, had a diameter of about 9 mm, a height of 14 mm and a weight of about 3 g. However, it quickly became clear that such studs are quite harmful to the asphalt surface. Studies have shown that installed on one car tires of this type gnaw from each kilometer of road more than 150 grams of asphalt. Tire makers had to develop serious scientific and design work, because the weight of the tire was legally limited and today is about 1 gram. It was possible to achieve this by abandoning steel bodies and switching to making them from light but strong aluminum alloys. Until recently, great expectations were pinned on the next step, i.e. the transition to manufacturing stud bodies from non-metallic materials, rubber or plastic. Of course, carbide cores still consisted of tungsten carbide, WC, with titanium and niobium carbides, TiC, and BC. The idea was that such studs would have a better grip in the tread body and that the deformation capability would allow the stud to bite into the snow and ice surface better, and the tests confirmed all this. However, it turned out that polygon tests are one thing, but the real operation is somewhat different. The bodies of touted non-metallic studs began to break down after a dozen or 2,000 kilometers. And all because plastic and metal have different coefficients of thermal expansion. Perhaps in the future we will see spikes made of metal ceramic, but today alloyed aluminum remains the almost alternative material for spike bodies. At the same time, the tires themselves also changed. There were models whose very design was adapted to the installation of studs. It was necessary to solve several problems at the same time, to increase the efficiency of studs, to reduce their impact on the asphalt surface, and to ensure that the stud is held in the rubber blocks as securely as possible. Here all developers go their own ways. First, each brand tries to find the optimal shape of the carbide tip. At one time, almost all used cores with a round cross-section. Production of such nails is the most technologically advanced. But year by year the shape of tips is becoming more and more complex, oval, hexagonal, with square cross-section in the form of a rectangle with and without protrusions on the corners. At the same time, the shape of the casing is also changing, and it is less and less often a rivet or a mushroom with a flat cap. On the stem of the fungus there is a peculiar neck, which contributes to better retention of the stud in the tread body. The casing itself is increasingly becoming asymmetrical, and the cap, the flange, is more often a geometric figure with rounded corners, rectangle, square or trapezoid. However, this asymmetry means that the stud will react differently to loads acting in different directions, which means that the orientation of the flange must be observed when installing studs. Accordingly, one of the well-known tire companies uses two types of studs with different flange geometry and carbide tip shape in its popular model, placed in different areas of the tread. But there is still the problem of dealing with loss of studs while driving. Here, too, each brand goes its own way. Some limit themselves to experimenting with the shape and size of the lower flange and the density of the rubber, while others offer rather radical solutions, such as the so-called soldered studs. Each stud is covered with a solidifying thermoadhesive mixture, and then the tire is studded. During the vulcanization process, the stud coating and the rubber compound are sintered to form a strong bond. The new studded winter tire is an example of how you can achieve your goals without using radical, albeit effective, but very expensive solutions. Toyo Observe Ice Freezer. We have already written about how it made an impression during the tests on an ice track. We have taken a closer look at the design features of the snow blades. These include such signature elements as snow blades, special protrusions in the shoulder zone that increase traction in deep snow, and ruts, asymmetrical pattern with interconnected tread blocks, high-amplitude 3D blades with sharp edges, rubber compound, made with microbit technology. We will definitely come back to it in the future. Multi-layer structure, where under the soft working layer of the tread there are layers of harder rubber, as well as a combination of multi-layer breaker, rigid polyester carcass and sidewalls with super strong filler cord. But in this case we are interested in the design of the spike itself and the way it is installed. On the one hand, the body of the branded spike, named Ice Force, has a rather traditional structure, i.e. a symmetrical round cross-section. However, the diameter of the body is reduced and the diameter of the flange, on the contrary, is increased, so that the spike resembles not even a mushroom, but a coil. This allowed, firstly, to increase the reliability of stud retention in the tread. The company believes that this parameter has increased by 20%, and secondly, to improve the placement of studs on the tread surface. In fact, it is very important that the stud crashing into the ice does not fall into the notch left by another stud, so its work will be much more effective. Accordingly, the studs in the tread are arranged in longitudinal rows, and usually the number of rows is limited to 10 to 16. Occasionally there is a 20-row treading, and this is considered a serious achievement. Toyo engineers have managed to increase the number of rows to 28. The tip of the carbide core of the Ice Force spike is pentagonal, and this provides excellent traction on ice, both during acceleration and braking, and in corners when the spike has to deal with lateral loads. However, the performance is also affected by the special shape of the holes in which the studs are mounted. The notches around them have serrated edges, which provides additional traction and also helps deflect ice chips from the contact area. Naturally, studs are installed in the tire's Toyo Observe ice freezer with the help of special equipment and under strict control. Tires manufactured in Malaysia are studded directly at the plant, while those manufactured in Japan are studded in Russia, since the use of studs in the land of the rising sun is prohibited by law. In principle, it is the reliability of stud retention that distinguishes a branded studded tire from universal studded tires, studded in some garage. After all, no one prevents you from buying a pneumatic gun, well, or find an organization that has this tool, stock up on any car. Market inexpensive studs and independently turn non-spike tires into studded. Moreover, there are inexpensive screw-in studs, which look like a self-tapping screw. You don't need an air gun to install them. The whole question is how many studs will remain on such wheels after the first intensive braking. Well, the tire's Toyo Observe ice freezer are an excellent example of how to achieve excellent results by using and developing quite traditional approaches without complicating and therefore increasing the cost of the design. But in any case, it is worth considering that one of the most important factors in the issue of preserving studs is the manner of driving. If you constantly drive in the summer manner in winter, abusing sharp acceleration and braking sharply and actively rearrange, regularly hit curbs, you have a much higher chance to lose studs during one season than the one who switches to smooth and quiet driving in winter. One more thing, modern hydraulic and electric power steering systems have quite enough power to rip out all the studs in the area of the contact patch during intensive steering at the moment when the car is not moving and at the same time stands on the asphalt. The studs are simply not designed for such lateral loads. Again, tire manufacturers do not get tired of repeating that new studded tires must be run-in, but too many car owners forget about it or simply do not pay attention. After all, the correct run-in implies that the first 500 to 800 kilometers should be driven at a relatively low speed, no more than 60 to 70 kilometers. Avoiding sudden maneuvers and braking, carefully controlling the balance of the wheels and maintaining the recommended pressure in the tires. And these 500 kilometers should be driven on asphalt, before snowfall. Why is it necessary? Yes, in order for the studs to take the correct position in the body of the tread, the rubber and metal rolled to each other, and the lubricant, which covers the stud before installing it in the tire, evaporated. If everything is done correctly, the rubber surrounding the studs will get used to the shape of the foreign bodies embedded in it, and the tire will start to work as it was intended by the designers. But in any case, the car owner who believes that by installing studded winter tires, he caught God by the beard and can now run on the highway and the city in the same manner in which he did it in the summer, risks his life, and the lives of his loved ones, and the lives of other road users. So once again we want to say, friends, please drive your cars carefully and cautiously in winter, even if you have acquired a set of excellent studded tires and properly rolled them up. In conclusion, the issue of spikes flying out of winter wheels is a significant concern for both safety and performance. Tire manufacturers have implemented various strategies to address this problem, including advanced materials, improved manufacturing techniques, and rigorous testing protocols. By focusing on durability and secure spike retention, they aim to enhance the reliability of winter tires. As drivers, it is essential to choose high-quality tires and ensure proper maintenance to minimize the risk of spike loss. Staying informed about these developments can help us make safer choices on the road during the winter months. Thank you for watching, and drive safely.